Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, for today's lesson, we're going to continue with our strategies for subtracting integers. And today I'm going to formally introduce to you my method that is my foolproof method for subtracting integers by changing the subtraction problem to an addition problem, and that is called KFC. Some of you may know it as leave it, change it, flip it, but I like KFC because chicken's delicious and I just like KFC better. So K stands for keep, which is the very first starting number. You want to keep it how it is. Flip it, that's your subtraction sign. Flip it to its opposite, which is the addition sign, and then change the sign of whatever number that was being subtracted from the first number to its opposite. So keep, flip, change, KFC. We're going to do this over and over and over again because we subtract integers, and it's not even for integers, it's for all rational numbers. We do subtraction a lot, but subtraction can be complicated. Adding is much easier, so I just prefer to change them to addition problems. So you have investigated relationships between addition and multiplication as well as subtraction and multiplication. I don't remember doing subtract. I guess we did a little bit of that. Okay. You also know that multiplication and division are closely related. Are these the only relationships between operations? Today, you will investigate this question as you look for relationships between subtraction and addition. Okay, so I'm changing this a little bit. I'm going to make it a little bit shorter for time's sake. It says put 10 negative tiles on your table, and with your team, find at least 4 different sequences of steps, either adding or removing any numbers of positive or negative tiles in each step, so that you end up with -4. So I'm changing this. We're not going to have tiles on our table. You could just draw 10 negative signs, and then you want to change that -10 so that it equals -4. And we want to try and do it in 2 different ways, okay? This might seem a little bit confusing, so I'm just going to have you watch me as I do it, and kind of so you get the gist of it. All right, so we're starting with 10 negatives, right? And our goal is to make that equal to -4. So what would need to happen there? Well, I was thinking if we were to add 6 positives, like add those 2 positives here and add these positives there, then -10 plus 6 will be equal to -4, right? Because all of these form our 0 pairs. There's 1, 2, 3, 4, 5, 6 0 pairs, leaving us with just -4. So that's one way of doing it. What's another way that we could do, that we could do this with 10 negative tiles? Well, remember that was the symbol for taking away. So if we started with -10 and we took away 6 negatives, we would be left with 4 negatives, okay? So are any of those appearing to be easier than the other? I mean, if you just look at the equations, let me go ahead and, sorry, I got a little OCD. If I drew a box from that one, I want to draw a box from this guy as well. Okay, so if you just look at the equations, it seems like this one's easier, because remember what we did in chapter 2. When you're adding 2 numbers together that have different signs, you subtract the numbers. 10 minus 6 is 4, and you keep the sign of the number that has the greater absolute value. So we're going to keep that as a -4. Another way that we talked about it was, do you have more positives or more negatives? We have more negatives. How many more negatives do we have than positives? Well, we have 4 more negatives than we have positives because we've got 10 negatives and 6 positives. So 10 is 4 more than 6, and they're negatives, so we got 4 more negatives. So I just think whenever you're working through this, it just seems easier to add 6 than to subtract the -6. Even though using the model, it seemed like, well, we could take away 6 negatives from the 10 negatives. But if you don't have the model available to you and you're just solving it this way, that seems confusing to me and is often confusing to students. So our goal is to see if this was just a fluke, that you could write -10 minus a -6 as negative 10 plus 6, and will it always work, or was this just something that worked for this particular problem? Okay, so let's try another model. Let's start with 5 tiles, 5 positive tiles, and try and figure out 2 different ways that we can come up with an answer of 2 positive tiles. Okay, so I showed you how to do it here. Let's see if you can figure out a way to model this. Okay, 2 different ways, starting off with 5 positives and ending up with only 2 positive tiles. Go ahead and pause, and when you feel you're ready and you've got your answer, go ahead and unpause, and I will reveal what I've got. All right, let's start with this. If we started with 5 and we took away 3, we would have 2, correct? So 5 minus 3 is 2. Well, that's pretty easy. You know, just basic subtraction with positive numbers. 5 positives, take away 3 positives, you're left with 2 positives. Okay, so that's one way of doing it. What would be another way to do that would be if we started with 5 positives, but we added 3 negatives to that. And remember, when you combine positives and negatives, they form 0 pairs. So you have 2 plus 0 plus 0 plus 0 gives you an answer of 2. So notice what we've got happening here. In this case, we had 5 minus 3, and in this case, we're going to, instead of subtracting 3, we're going to add the opposite of 3 to get the exact same answer. So here we've got 2 different situations where that process worked for us each time, starting to become a trend. All right, so now let's do this. Let's rewrite 7 minus a negative 2 as an addition expression that gives the same result. Justify your addition expression using integer tiles. Okay, so go ahead and copy 7 minus a negative 2 and model that as an addition problem and see if you can get the correct answer. Pause and then unpause when you're ready. All right, so let's see what I did here. We start off with 7 positives, but we're supposed to take away 2 negatives. Problem is, we don't have any negatives. So we had to add some 0 pairs so you could take away 2 negatives. So 7 minus 2 negatives, once those 2 negatives got taken away from the 0 pairs, you were left with 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer to this expression is positive 9. That looks complicated. But what if we rewrote it as 7 plus 2 instead? So instead of subtracting a negative 2, we added the opposite of negative 2. Do we get to the same answer? Yes, we do. So which one of these two seems easier? 7 plus 2, I would say, is much easier than 7 minus a negative 2. Really? Because, I mean, seriously, you're trying to take away 2 negatives when you don't have any to begin with, which means you've got to add some 0 pairs before you'll be able to take away those 2 negatives. So definitely easier changing it to an addition problem. So does this always work? Do you think that every subtraction problem can be rewritten as an addition problem that gives the same result? Go ahead, copy down all of these problems here, all these expressions, and see if you can come up with an answer for each one of them. You can notice I've got all the answers behind these boxes. I will reveal in a moment, okay? So I'm going to pause, you pause, and when we come back, we'll do the reveal. All right, so if you take 6 plus a negative 2, without using our tiles, let's just think about our integer rules from last chapter. You have different signs, so that means there's going to be a subtraction happening here. And you have more positives than negatives, so your answer is going to be 6 minus 2 is 4. It's going to be positive 4. And that's exactly what this says, right? 6 minus 2 is positive 4. Here is 7.85 minus a negative 5, the same as 7.85 plus 5. Turns out it is. In both cases, your answer is 12.85. What about here? Is negative 3/5 minus 3/10 the same as negative 3/5 plus a negative 3/10? Well, this ends up being negative 6 over 10, so our answer is negative 9 over 10, and that's what we end up getting here as well. Here, -8 minus a -12, is that the same as -8 plus a +12? Yes, it is. Our answer in both cases is 4. If you don't believe me, I will actually prove that one. 1, 2, 3, 4, 5, 6, 7, 8. I'm supposed to take away 12 negatives, but I only have 8 negatives. So I'm going to add 1, 2, 3, 4 zeros. Now I can take away 12 negatives, and that leaves me with 4 positives. So that absolutely works. Okay. What is 0 minus 5? Think of the number line. Start at 0, go 5 units to the left. You're at -5. 0 plus anything is equal to itself, so this also has to be -5. So we should feel pretty confident that each one of those is always going to work and give us the same answer. So this process, do you think that every subtraction problem could be rewritten as an addition problem that gives you the same result? And the answer is yes. And I would like for you to copy this down. Every subtraction problem can be rewritten as an addition problem by adding the opposite of the number being subtracted from the starting number. That's what KFC is all about. You keep the starting number the same, but instead of subtracting, you flip it to the plus sign, and you take the number that was being subtracted away and you change it to its opposite number. So adding the opposite, KFC. Okay. I'm going to move on. If you want to pause it so you can copy all this down, go ahead and copy it. All right. So what we're going to do now is we're going to take all of these problems and we're going to rewrite them as addition problems using KFC. So wherever, after you copy down the problem, write a K above the starting number, the F above the minus sign, and the C above whatever number is being subtracted from the starting number. Then rewrite the expression. So that becomes -100.86 plus +3.86, and then simplify that by using our integer rules. You've got more negatives than positives, so you're going to have a negative answer, and you'll subtract those numbers. What is 100.86 minus 3.86? That's going to give you your answer here. Make sure you remember the negative sign. A lot of times students forget, they lose track of the negative sign. Make sure you've got that written in, okay? Copy all of these down, then we'll do the reveal, and then I'll have one final statement for you before we call it a day. I'm going to pause as well. All right, so what did we get for our answer here? We should have gotten, is that -97? Yes, it is. That is -97. For here, instead of 21 minus a -7, you would rewrite that as 21 plus a +7. And what is 21 plus 7? That is 28. For this problem here, instead of -24 minus 6, we'll write it as -24 plus a -6. Hey, stop it. Well, I guess maybe I'll do that. There we go. Okay. So now we've got integer rules where we're adding two numbers with the same signs. Remember our integers. If you have 24 negatives here and 6 negatives here, you put them all together, there are no zero pairs. There's no pluses in there anymore, no positive integers. Just negatives and negatives being added together. How many total negatives are there? Well, total of 30 negatives. So the answer to that is -30. For this problem, instead of saying -4/9 minus 3/9, change it to -4/9 plus a -3/9, right? Keep change. That becomes a plus sign, that becomes -3/9. So now you're adding two numbers that have the same sign, just like we did here. So you're going to add the numbers and keep the sign, and that gives you -7/9 for your answer. Here, instead of saying 0 minus 1.12, let's call it 0 plus a -1.12. And remember, whenever you add 0 to a number, it doesn't change its value. So that's going to stay as -1.12. And in the last case, instead of 0 minus a -37 1/4, let's keep the change and make it 0 plus a positive 37 1/4. And so now your answer is obvious. 0 plus anything is going to be equal to itself. So our answer is 37 and 1/4. Okay, so KFC is your friend. With your team, decide which of the following expressions you would want to retry and why. I would say all of them should be rewritten because subtracting is not that easy to do. Adding is a much easier operation than subtracting. So, KFC, use it anytime you've got subtraction problems, and it should make your life a lot easier. Now, you will, once it's an addition problem, have to go back to our basic rules for adding integers together, adding any positive or negative numbers together. If the numbers are the same sign, like here, you add the numbers and you keep the sign. If you're adding numbers with different signs, there's going to be a subtraction, and you're going to keep the sign of the bigger number. So do you have more positives or more negatives? How many more negatives do you have? Do a subtraction process and make sure you attach the appropriate sign to your answer. Okay? All right. This, once again, these are all foundational skills. You'll be doing this throughout all of 7th grade, throughout all of 8th grade, and all of high school and college. These are the types of problems you'll need to know how to solve, and this is a great strategy, KFC, for helping you when you're dealing with subtraction, with negative numbers especially. All right, take care. Good luck on your homework. Swallow your work.
Hey, feeling good, like I should.